Hey, Topic Life Math and History, and we are gonna take a look at perpendicular lines. So in the past few videos for geometry, we've been learning a lot about segments, a lot about with angles. We also been learning about acute angles, obtuse angles, right angles, and a lot more. But what are perpendicular lines? Well, perpendicular lines have to relate with right angles. And it means that there are 90-degree lines that look like this, that are side by side each other. This side is 90 degrees, and this side is 90 degrees. And they both add up to 180 degrees. So that can be an example of a perpendicular line. So, since we now know what perpendicular lines mean, we can now understand how we can use them in problems. Oh, and when a problem is stating you that this line is perpendicular with that line, or these two are 90 degrees, then you'll often see this symbol right here. Sometimes your math teacher will just spell out the word perp. Is a short phrase for perpendicular, but it's most common to use this symbol right here. Let's get started. So to start off, let's start with using a symbol by identifying a picture. So here's an example of where we can use the symbol. We have a diagram that have two lines that crisscross each other, and the square right there means it's 90 degrees. We could also say that this side is also 90 degrees, along with this side, and this side can be 90 degrees too. But what we're going to focus on in today's video is the top ones right around here, which equal 180. What we can say by using the symbol with this thingy right here is line A, we can say that A is going to be perpendicular with B, which both make the 90 degrees. Here's an example where it would not work. So right over here, these are not 90 degrees. They're not equal to. So we can say that these ones are called oblique lines. They try to be perpendicular lines, but oblique lines are basically lines that have more width between them, and they're more obtuse and sometimes more acute. They're not perfectly 90 degrees. You can see an oblique line in the famous Scottish flag, something that looks like an X. And in this statement, we can say that A can be not perpendicular to B. Not means that you would cross it out. A is not perpendicular to B. Well, we place A right here and B right there. So it's not going to work with an oblique line. So now I guess we can understand how to use the symbol for perpendicular lines. Now we're going to go into a proof and see how we can prove that two lines can be perpendicular. So here is our problem. What's given to us is line segment AB is perpendicular to line segment BC. And we can also understand that line segment DC is perpendicular to BC. We gotta prove that angle B is congruent with angle C. And here is what our picture looks like. So AB is congruent with BC. DC is congruent with BC. And we gotta prove that this angle right here is exactly the same measurement as this angle right here. That dives down to another thing with perpendicular lines. So, you may think that when you think of perpendicular lines, they look like these. But perpendicular lines can also be something that looks like this, where there's one 90-degree line right here, and another 90-degree line right here. The definition of perpendicular lines is we can say two 90-degree angles that will bring you to perpendicular lines. So the only rule is you must have two 90-degree angles, and they can be pronounced as perpendicular. This is how you normally see it, but this is another way of seeing it. And that's why you probably got confused when it said that right here is perpendicular to right there. They're not exactly back to back like this, but they can look like this, and it's still following the rule. Let's start with our proof. So given to us, we said that AB is perpendicular to BC as segments, and also DC is perpendicular to BC as segments. Those were our given phases to us, the problem that was literally given to us. Another thing we can understand that angle B is a right angle. And we could say that perpendicular lines can bring you to a right angle. That's saying that angle B is a right angle. Now we can look at another thing. Going from this one right here, this one should actually be down here because it's explaining that DC is perpendicular with BC. That was given to us. And that is going to understand and link to that angle C is a right angle. And we could also say that the perpendicular line can bring us to another right angle. That is saying angle C is also 90 degrees. These two are now perpendicular. And not only that, we now have proved that angle B is going to be congruent or the same as angle C because they're both 90 degrees. And here is our rule or our formula. Two right angles can bring you to perpendicular lines. So we have proved that B and C are not only perpendicular, but they're congruent as 90 degrees each. So that is how we can prove with congruency and perpendicular lines. Let's look at one more example. Okay, so here is our final example. Well, this is a reminder saying that segments TO and OA is perpendicular. So we could also say that to make a perpendicular line, we could say that TO and OA are the elements or the ingredients that we need to make a 90-degree angle. We can say that this right here is 90 degrees since perpendicular lines must have 90-degree angles.
I guess Grandpa SquarePants was right. Don't run for a bus. Especially one that's going up at a 90-degree angle. I better go wait for the next one.
So in this scenario, we're going to find angle 1. So, if angle 1 right here is unknown, and angle 2 is 60, we can easily say that 90 degrees subtracted by 60 degrees is 30 degrees. There we go. Angle 1, the measurement of angle 1 is equal to 30 degrees. There we go. And that is how we can understand and also learn from perpendicular lines. I hope this video has helped you understand perpendicular lines. Thank you for watching Top Opinion Lines Math Industry. Like and subscribe.